In this video, we will discuss risk assessment and risk management of total petroleum hydrocarbon, or TPH. First, we will explain a little about the tiered TPH Risk Assessment Framework, which is really our roadmap through the risk assessment process. Then we'll dive into the specific elements of a risk assessment and finally conclude with different risk management options that are available and how they can reduce or eliminate risk at your site. Behold the tiered TPH Risk Assessment Framework. Although this flow diagram looks busy, it's really following the traditional risk assessment approach of first conducting a Tier 1 screening level risk assessment, which I've circled in yellow. This is basically the process of screening your existing data set against default screening levels to determine whether concentrations are acceptable because they are at or below the screening levels, abbreviated as SLs. If your concentrations are at or below screening levels, your site does not pose a risk, and you should be able to request a no further action, or NFA, for your site. In some instances, additional monitoring may be required for certain media, like groundwater or indoor air, because concentrations in these media may change over time. If your data end up exceeding screening levels, you may want to forgo collecting additional data and go straight into managing your risks by selecting risk management options that are appropriate for your site. However, you may choose to collect additional data and use that data to conduct a Tier 2, Tier 3 site-specific risk assessment, which requires gathering information on potential exposure pathways and toxicity of chemicals exceeding their screening levels. As shown circled in pink, the Tier 2, Tier 3 site-specific risk assessment can be a cyclical process, whereby the data, exposure, and toxicity inputs can be refined to make them more site-specific in hopes of calculating risks that are less than the target threshold, which is typically identified as the cancer risk or non-cancer hazard index. If the initial or refined cancer risk and non-cancer hazard index are acceptable, your site does not pose a risk and you should be able to request a no further action, or NFA, for your site or agree to additional monitoring for certain media. If your refined cancer risk or non-cancer hazard index are still unacceptable, you will be required to manage your risks by selecting risk management options that are appropriate for your site. Let's go into more detail on how to conduct a Tier 1 screening level risk assessment. As I mentioned, the Tier 1 screening level risk assessment is the first step in understanding how exposure to TPH may be occurring and whether that exposure is a human health concern. Therefore, the very first thing to develop in a Tier 1 screening level risk assessment is a preliminary conceptual site model, or CSM for short. This is typically a graphical representation of source release and migration of TPH into the environment, resulting in potential TPH exposure to workers, residents, recreational users, trespassers, construction workers, and others. Once the preliminary CSM has been established, you can identify which screening level category to apply. For example, if your industrial site is fenced, limiting site access to workers only, you would most likely screen your data against industrial screening levels. However, if your site extends into a residential area, you should screen your data against residential screening levels as well. Once appropriate screening levels are identified based on exposure, a review of the initial data set is crucial, including understanding what kind of TPH data are available and whether there are screening levels for that data. This may also be a good time to check in with your regulatory requirements on TPH data, especially if you have limited or no TPH data. If you have no existing TPH data, collection of both bulk TPH and individual indicator compounds is highly recommended. Once you collect the appropriate TPH data set and identify the right default screening levels, you're ready to screen your data. The preliminary CSM will also help identify which exposure pathways are complete. For example, if drinking water is supplied by the city and there is a prohibition on installing drinking water wells, you can safely assume drinking groundwater is not a complete exposure pathway. However, if the groundwater has volatiles and the plume extends under a residential building, inhalation of groundwater volatiles in indoor air may be a pathway of concern and would require further evaluation regarding the vapor intrusion pathway. The PVI pathway is the subject of 4 separate videos in this collection. I recommend checking them out if you are navigating PVI at your site. If your Tier 1 screening level risk assessment identifies screening level exceedances and you don't want to immediately select a risk management option, the next step is to conduct a Tier 2, Tier 3 site-specific risk assessment. A Tier 2, Tier 3 site-specific risk assessment requires identifying data gaps and collecting additional data to further characterize what's in the TPH. The additional data may include bulk TPH data and chromatograms, indicator compounds, and TPH fractionated data. If you watch the TPH fate and transport video, you understand that in addition to differentiating between aromatics and aliphatics, identifying TPH fractions within these chemical classes is helpful when looking at TPH compositional changes, metabolite presence, and how these issues affect TPH risk. TPH fractions are essentially groups of hydrocarbons with similar characteristics. It's helpful to think in terms of TPH fractions, similar groups of hydrocarbons, for both composition and risk. Once the appropriate data have been collected and CSM updates have been made, the remainder of the Tier 2, Tier 3 site-specific risk assessment includes selecting site-specific exposure assumptions and toxicity information in order to characterize risk specific to the site. As part of the Tier 2, Tier 3 site-specific risk assessment, an exposure assessment must be conducted. As discussed in the TPH fate and transport video, once TPH enters the environment, it can be chemically transformed, which is called environmental fate. TPH fate can be driven by biological weathering and how weathering changes the compounds that make up the TPH mixture while creating petroleum metabolites in the process. In addition to environmental fate, TPH can migrate from one media to another, which is called environmental partitioning, where it ultimately ends up in an exposure media like groundwater or indoor air. Once TPH migrates from the source to an exposure media, a person may contact TPH by ingesting groundwater or breathing indoor air, for example. This diagram shows several TPH sources and how they can migrate in the environment, ultimately reaching an exposure medium. In addition to an exposure assessment, a toxicity assessment must be conducted as part of the Tier 2, Tier 3 site-specific risk assessment. Now here's a tricky question. How do we assign a toxicity value to TPH when we know that TPH is a mixture containing thousands of compounds? The three basic approaches to TPH toxicity assessment are shown, including the indicator compound approach, the whole product approach, and the fractionation approach. The assumption underlying the use of the indicator compound approach is that the indicator compounds represent most of the mixture's toxicity and therefore the health risk of the entire mixture. Contrary to this assumption is the fact that the indicator compounds often make up a small fraction of the mass of their representative TPH range and are more toxic than the rest of the compounds in the mixture. Therefore, this approach will likely overestimate risk. Under the whole product approach, a single toxicity factor is assigned to a whole petroleum product, such as gasoline, diesel fuel, jet fuel, bunker fuel, crude oil, etc. The primary drawback to this approach is the fact that the composition and toxicity of the product will change as it weathers and could only be applied to fresh releases. The whole product method of evaluating the toxicity of TPH entails more uncertainty than is associated with health risk estimates based on measured TPH fraction data. Therefore, the whole product approach is appropriate for a Tier 1 screening level risk assessment, but should be used with great caution, if at all, for a Tier 2, Tier 3 site-specific risk assessment. Under the fractionation approach, TPH is divided into aromatic and aliphatic compounds, and the aromatic and aliphatic compounds are further divided into several defined carbon ranges. The fractionation approach is intended to supplement the indicator chemical approach in evaluating TPH, especially when indicator compounds are not present at detectable levels. The fractionation approach also can be applied to any TPH mixture, resulting in better characterization of TPH risks at the site. If you watch the TPH general chemistry video, one of the questions posed is how do we measure TPH in the environment? The answer lies in the TPH analytical method that is selected, as the analytical method defines TPH and provides an approximate concentration of total hydrocarbons in a complex mixture. This graph presents TPH analytical methods on the left and number of carbon atoms across the top. Aliphatics are presented in green and aromatics are presented in orange. The bottom of the graph translates the TPH analytical method fraction intervals, the green and orange boxes, into TPH fraction-specific toxicity values to help characterize risk. If you recall, in the TPH Fate and Transport video, we discussed US EPA's toxicity fractions, low, medium, and high, for aliphatics and aromatics. This table illustrates the variability in oral non-cancer toxicity values, which are identified as oral reference doses, or oral RFDs. Lower oral RFDs are more toxic than higher oral RFDs. If you look across the range of low aliphatics, you will see that it spans 2 orders of magnitude. Therefore, it's important to pay attention to your regulatory requirements when assigning toxicity values to TPH fractions. As discussed in the TPH Fate and Transport video, biologic weathering, also called biodegradation, is a major contributor to TPH hydrocarbon mass reduction in the environment. In addition, biodegradation generates petroleum metabolites that can be further degraded in a stepwise process. How do we address metabolites when conducting a risk assessment, especially when toxicity information on individual metabolites is limited? The answer may depend on your regulatory agency guidance on metabolites, if they have one. 3 approaches for evaluating the toxicity of metabolites have been proposed. One assumes that metabolites have the same toxicity as the bulk hydrocarbons in the TPH fraction. A second approach assigns toxicity factors for individual metabolites, and a third approach excludes metabolites from the risk evaluation altogether. Understanding how to conduct a TPH risk assessment starts with understanding the TPH source mixture, as well as the fate and transport mechanisms, including weathering processes that may occur at your site. We spent a lot of time in this video discussing TPH analysis and how this will impact the rest of your risk assessment, especially your selection of screening levels and toxicity values. For the initial Tier 1 screening level risk assessment, collection of bulk TPH data and indicator compounds can be helpful in identifying risk. If a Tier 2, Tier 3 site-specific risk assessment is required, collection of TPH fraction data is essential to characterize the TPH mixture and assign appropriate toxicity values when calculating risk. It is so important to understand your TPH regulatory framework, as this will help you navigate this risk assessment process at your site. One topic we haven't mentioned until now is risk management. There are several risk management options that can be used effectively to prevent exposure both on-site and off-site. When your site impacts haven't been fully characterized, you can always collect additional data to refine the Tier 2, Tier 3 site-specific risk assessment and better characterize the TPH mixture. If your additional data collection days are over, there are 4 risk management options that could serve your site, including remedial action, mitigation, engineering controls, and institutional controls. Remedial action is a physical approach to remove contamination or chemically transform contamination into something non-toxic. This could be excavating soil or treating groundwater contamination. Mitigation is also a physical approach to move contamination away from or keep it from entering an exposure medium like indoor air. This could be an active subslab depressurization system to move soil vapors away from the building's foundation and into ambient air. Engineering controls is a physical approach to keep contamination in place to prevent exposure. This could be a barrier wall constructed in the ground to keep contamination in place. And finally, institutional controls are administrative or legal agreements that can be exercised to prevent exposure. This could be a deed restriction to prevent groundwater use or prohibit groundwater well installation to keep people from drinking groundwater. If you are interested in obtaining additional information on PVI, LNAPL, or TPH, please visit the following ITRC websites, which contain links to both guidance documents and fact sheets.
The Interstate Technology and Regulatory Council is a nonprofit research program of the Environmental Council of the States. ITRC is a state-led organization composed of over 1,000 members from state agencies, federal government, tribal and international organizations, the private sector, academia, and community stakeholders. Members participate in technical teams which produce guidance, tools, resources, and training materials. If you'd like to be a part of ITRC, please visit the ITRC website at itrcweb.org. You can register for teams and learn more about how you can be an active member. ITRC's usage policy is available on the ITRC website. If you do plan to use ITRC materials, we ask you to review that policy in detail and be sure to credit ITRC. ITRC does not warranty the material nor endorse any specific